This lecture comes from Chapter 12, Modules and Functions, of my book, Computer Scripting Techniques with Python. Now, I talk about modules and functions because modules and functions are your fundamental Python code organizational foundation, I guess you would say, right? You have to have a module, like the main is a module, main.py, and then how you organize your application from an architectural standpoint. You should put different components in different modules, right, for conceptual complexity taming purposes. Now, we'll talk about this stuff as we progress. But anyway, Chapter 12, Modules and Functions. Let's go over some of the learning objectives before we dive into the meat of the matter. Learning objectives state the purpose and use of modules and functions, state the naming conventions used to name modules and functions, explain what it means to minimize coupling and maximize cohesion, define the terms parameter and argument, use the keyword def to define a function, state the purpose of function parameters, explain the scoping rules for function parameters, pass arguments to functions, return data from functions, explain why functions are considered first-class objects, pass functions as arguments to functions, use docstrings to document code, use keyword parameters in function definitions, define default argument values, and employ special parameters, star args and star key args, keyword args, it's KW args, quargs, I guess you could pronounce it, in function definitions. So there's a lot to cover in this video. So let's dive into it. First, a brief introduction. Modules and functions form the bedrock of reusable code, right? If you've read chapters 2, 3, and all the chapters in between, all the examples so far in the book, then you're already acquainted with modules and functions, right? As well as methods. Like in Chapter 4, Project Walkthrough, I use a class to implement that robot rat project. So, like I say, you're going to learn the purpose of modules and functions, and I'm treating these two concepts together in one chapter because both modules and functions are used to enforce, like, organize your source code, right? And modules especially, right? So modules are your first line of code organization defense. Now, with regards to functions, you learn how to define a function, how to name a function, how to declare function parameters, how to pass arguments to functions, how to return data from functions, and why functions are considered first-class objects. Now, I guess some people may say, oh, a function is just you just gather up some code and put it in a function. Function's more than that, right? You don't want to just willy-nilly gather up a bunch of code and stick it in a function. You want the function to have a singular purpose, perform one well-defined task, and without causing unknown side effects, right? This is a term called maximize cohesion. You also don't want that function to be too interdependent on other things outside of itself, right? Of course, you're going to be dependent on library calls, but you don't want to. You want to minimize the coupling to other objects, okay? To the fullest extent possible, right? This isn't a all or nothing thing. Now, something to keep in mind, many of the concepts I discuss in this chapter trace their origins back to the software crisis of the 1960s, when programmers grappling with ever-increasing software complexity began to formalize and codify software design and coding practices in an effort to write more reliable, reusable, and maintainable code. This is very interesting when I was doing research, right? Because, when you go to school and you do software engineering for 10, 15 years or more, right? You begin to kind of lose well, why am I doing this stuff? And where did it originate, right? Like I was taught how to do things in school. And then I carried that over into my professional career. It's not like I never asked why, but when I was researching this book, I wanted to go deeper into what were the historical origins of some of these things, right? And it turns out that most modern languages implement these concepts because these are the things that were on software engineers' mind before there was a term software engineering, right? They were on the people's minds who were building these computers, figuring out how to go from writing assembly code or machine code in some cases to building more complex systems, and how do you tame the complexity when you get into bigger software systems. That's really the issue, right? How do you tame that complexity, right? And one of the first things that we find is we use modules, right, in order to implement common behavior. And so we will start with modules and what they mean. What does a module mean in Python, etc. So let's start with Python modules. A module in Python at its most fundamental level is a file that contains Python source code. And by convention, a Python source code file ends with the suffix .py. Okay, so that when this file is read into the interpreter knows this is a Python source file. Okay. Now the name of the file becomes the module name. And more specifically, it's the module's __name _ attribute, right? Like, for example, I'm going to have to show you all this. Every Python object has metadata associated with it, and every module has a name, amongst other metadata, has a name attribute, and the underscore, correct, specifically, __name _ is an attribute of a module, among other attribute names, right? And it is set to the file name minus the py suffix, right? So whatever, when the name of the module under normal circumstances, and I have another video that shows like importing this stuff, and I'll probably do that again in this video. When you import a module into the interpreter, Python interpreter, it sets its ___ name attribute to the module's name minus the .py suffix, unless the module is directly executed by the Python interpreter from the command line and serves as the entry point to the application, in which case its ___ name attribute is set to a string value, which is it's going to be a string value anyway, right? But __ main __. Okay. Now, in Chapter 5, I have a section on how Python runs programs on page 106. So I recommend going to refer back to that section if you want to learn a little bit more. Modules serve as the first line of application code organization or architecture. An application architecture is a conceptual and physical assignment of responsibilities, features, and services to application components, right? A thoughtfully designed application architecture is easier to comprehend and maintain than one that is poorly designed. And simple Python scripts may contain only one module, while more complex applications will consist of multiple modules. So going forward, you will need to know how to name modules as well as what to name them. Okay. Now, I want to take a minute here to kind of show you like what a complex Python project looks like and how many different types of modules there are. Okay. So give me 1 second. All right. I pulled up a terminal and I'm going to navigate to a current Python project that I'm working on. Let's see, KISO API lib, CLS, and I'll open this up in Visual Studio Code. And I'll bring this over this way. So, in a nutshell, this is this is an application that processes data, energy data, from CAISO, California ISO. You can look it up online, CAISO. And I have, let's see here. I have a source folder, I have a test folder, I have a docs folder, I have downloads, I have line protocol folder, I have XML files. Okay, I have a build file. All right, here's my build.sh script. Now let's take a look at the source, because this is where a lot of the Python code is. Now the source folder is divided into subfolders: ingesters, notifiers, Oasis. And you can tell by looking at this structure that I have a main module right here. And this main module serves as the entry point for this application. All right, and it says right up here in the comments, entry point for the CAISO data ingest operations. All right, and then I have all my imports, what I'm importing from. And what I've done is I implement this stuff using workflows. And a workflow is kind of is a structured, like, download data from the website, process the data. There's a certain number of steps for each workflow. Each workflow could be customized. Okay. But when you run this application, it says, oh, okay. It takes a set of command line arguments. And then if we run this thing and we say launch or process the PRC underscore CURR underscore LMPS, then that means execute the underscore PRC underscore CURR or price current LMPs underscore workflow. All right. So now where is this price current LMPs underscore workflow? Just to trace this through, right? So we have price, we have Oasis workflows, price current LMP workflow. And then there's the class name, price current LMP workflow. So we go to ingesters. Oh, we have Oasis, that's the namespace. Workflows. Here's all the workflows. So price current LMP workflow. And the workflow uses a base CAISO workflow and LMP for value objects. Okay. So here's the class name, price current LMP workflow. Here's the initialization method, init, underscore underscore init, underscore underscore. And then there's an execute method, method, right? These are all methods because they're part of this class. So you can see that in order to impose some type of organization, like this is a module name, data extractors, file extractors, queries, reports, those are modules. And then the value objects I use, that represents the data within the application. So that's a module, that's a module, that's a module. And then for the workflows, that's a module, that's a module, that's a module, right? All these are different individual modules. When it comes to object-oriented programming, if a module implements a class, I have a rule that one module maps to one class definition. And that makes it easy for me to say, oh, that module AS underscore or auxiliary services underscore requirements underscore day ahead market workflow maps to this class, AS Rex Dam workflow, right? There's decorators, logging service, that's a logging service module, settings module. All right, so that's a complex Python application. And if I didn't bust this stuff up into multiple modules, I'd be lost, right? So that's really the point of me showing you this. All right, so let's move back to the lecture here. And I'm going to minimize this window. All right. Now module naming. Let's talk about module naming. Okay, you know, if you're going to have multiple modules, you're going to have to name these things. And PEP 8 style guide for Python code. If you've never seen the PEP 8 style guide, I believe I can just click this link right here in this document. All these links, I believe, are checked and double checked in the PDF file. But this is the PEP 8 style guide for Python code. And PEP 8, pretty much, if I sit here and say, oh, you should do this or that, or you should name these things this way or that way, I'm not making this stuff up, right? Python has a suggested style guide. Now, why would you want to follow the suggested style guide for Python? Why not just make up your own shit, right? Because when you show your code to someone else who's a Python programmer, they're kind of expecting your code to adhere to some type of a guideline with regards to naming, right? And if you don't follow naming guidelines, you can find yourself in a pickle sometimes, right? Like there's certain characters you can and cannot use in a file name. There's certain characters you can or cannot use in a class name. You should name your functions a certain way. There's a certain, you can add an underscore if the function is meant to be private and not used as part of the public interface, right? So there's all kinds of different considerations to think about. And PEP 8 style guide talks about those considerations, right? So, okay, so regarding module names, PEP 8 recommends using short, all lowercase names. You may use underscores in a module name to improve readability, all right? Generally speaking, if you're separating multiple syllables in a module name, you can use an underscore, right? So let's take a look at some valid module names, okay? Now, where do these come from? When you name something in a Python program, be it a module, a function, a variable, class, or other object, you are creating an identifier formed from a set of characters recognized as valid in the programming language. Python defines these in section 2.3 of the lexical analysis section of the Python documentation, right? With modifications and additions listed in PEP 3131 supporting not ASCII characters. Here's the short story. Valid identifier names include uppercase characters A through Z, lowercase characters A through Z, numbers 0 through 9, and underscores. A module name can start with an upper or lowercase character followed by upper or lowercase characters, numbers, and underscores. However, by convention, and as described in PEP 8, use only lowercase characters, keep module names short, and add underscores as necessary to make the module name easier for mere mortals to decipher. So essentially it boils down to this. Lowercase characters for module names, separate multi-syllable module names with an underscore or for readability, and keep them short as possible. You don't have to keep them so short. You name it what you need to name it, but don't make it just just randomly long, right? So here's a few examples of module names. Computer simulator.py, good, but computer underscore simulator would have been even better, right? Utils, okay, but vague. Disk utils, much better, right? Disk underscore utils. Classes, nope. This module name provides no hint regarding the module's intended purpose. That's another thing too, right? You can have a name of a module, but what does that module name convey? It should convey some type of purpose for the module, right? My first program, that's a valid module name and one that a lot of beginners use, right? So hello world, another beginner module name, fine. Person.py, okay, but favor the use of lowercase characters. Person.py, all lowercase, would be the one to go with, right? Not capital person. Now the class definition would have a capital P, all right? And then here we go. Here's just a module called L89G5.py. Nope. It's a legal module name. That's awful because it has no hint as to what's in it, right? All right, so then now that you know how to name a module, you know what valid characters you can use, you need to put some thought into what the name what name you're going to use for a module. Again, PEP 8 offers some guidance. It recommends you name modules according to their function, not their implementation. But what does this mean exactly? It's easier than it sounds. And in my opinion, beginners struggle with module naming mostly because they're not exposed early on to complex application architectures, right? In other words, unless you work on an application that can be logically organized along distinct boundaries of responsibility, you will generally tend to throw all your source code into one all-encompassing module and be done with it, right? That's about the worst thing you can do. So, for example, an application that requires some sort of interaction with a user, this interaction might be via a console or graphical user interface. The same application might also process data entered by the user and store it in a database. From the viewpoint of responsibilities, the application can be considered to consist of three: user interface, application logic, and data storage, right? Or database logic. A naive implementation of such an application may group all these responsibilities into one monolithic module as shown in figure 12-1. So this is figure 12-1. And here we've got the user running the application, and it's a naive app is what I've called it here, because everything is in one module, right? All the user interface stuff, the application and database code, and you got your database sitting over here to the side, like MySQL server or something, right? Single applications are not bad per se, right? But they do become problematic as application complexity increases. I think that's the biggest point to keep in mind. And so if the naive application in figure 12.1 expands in scope, it will prove helpful to structure the application into multiple modules whose names reflect their responsibilities, as shown in figure 12.2, right? So a better way of implementing this, right, would be have a separate module for the user interface, have a separate module for the application, and have a separate module for the database, whatever you end up naming these things, right? That makes it easier for you to figure out, oh, my user interface module has my user interface stuff. It uses the services of the application code or the app module, and the app module uses the services of the database module, right? I personally like to add another explicit entry point, right? So for example, if you notice in that last complex KISO example I pulled up, I have a main.py. That's where I run the program, right? So I add a main.py that then calls into the user interface, gets things going, which then uses the app and then the database, right? So this is just a better multi-layered architecture approach, and your modules should reflect the architectural organization that you're imposing on your application. All right. So a quick review: modules contain Python source code. The name of the module minus the PY is the module name. When that gets loaded into if it gets imported into the interpreter, then the name of the source file minus the PY is the module name. But if you run that module straight from Python on the command line with the Python command, then it'll change it from the module name to __ main, right? And you've seen that in a previous video. Now, let's talk about functions. Let's talk about functions, the 10,000-foot view. Okay, you may be wondering what goes into a module at this point. Functions, among other things. As you learned in the previous section, modules serve as the primary means for organizing an application's architecture. Functions can be used to organize code within a module. Okay, so modules are your top-level organizational element. And then within a module, functions. You can use functions, classes, okay? Other things can be in a module, But we're talking code organization, so you don't just want to willy-nilly throw stuff into a module, right? So if you want to organize your code within a module, organize it into functions or classes, but we're not talking about classes just yet, right? Now, you're already familiar with functions because you've encountered a handful of Python's built-in functions up to this point, including float, which is used to convert a string to a float, input, which takes input from the console and returns a string, int, which converts a string to an integer, print, which prints output string to the console, a reper and string are the representation, a string representation of objects, right? So anyway, you'll get the opportunity as you progress through this book to use more Python built-in functions. Now in this section, you get a high-level overview of the purpose and use of functions and several design considerations to take into account when you create your own functions. And this will prepare you for a deeper dive into and how to define and deploy functions and methods, right? Because everything you talk about functions apply to methods as well. So what is a function? Good question. And the answer depends on your point of view, which there's 2 points of view. You got the client and the developer. Now, if you're using a package, you're using a function, like you're using a built-in function, let's say, then that's the client point of view. If you use a function in your code, all you care about is the function's name, how to call it, what data you can pass to it, and what data it returns, right? You only care about the function's interface and what it does. You don't care how the function performs its intended task, nor should you ever need to know how the function performs its intended task, right? So in this particular manner, a function can be thought of as a black box, right? So this is what we have here in figure 2-4, a function viewed as a black box, right? So we have client code represented by the UML stick figure. And this client code is calling a function f, and optional, if you need to pass data into f, then you're going to use input parameters. And if there's a return value, then that's how you get data out of the function. There's other ways to get data in and out of a function, right? But parameters for data coming in, and generally a return value for data coming out, right? And we'll learn different nuances on this as we progress. Now, if you're the developer, right, this is the second point of view, you're designing and writing functions, then you need to know how to do such that users, including yourself, needn't care about how the function performs its task, right? So to you, the function developer, a function is a logical grouping of code accessible by name. The function's name should indicate its intended purpose or task, and all the code contained within the function should support the function's intended task and pull no surprises. This is called maximally cohesive function, right? If a function requires input data, then you need to define one or more function parameters to convey this data into the function. If the function returns a result, then you must define and implement a data structure suitable to convey the data back to the user. Now, this could be a fundamental data type like a string or an integer or a float, or it could be a class, okay? Functions impose structure, order, and clarity upon the code located within its containing module. Functions provide a means of code sharing and reuse. Functions make it easier to think and reason about program behavior. Properly implemented functions make code easier to maintain. And I'll go one step further, right? Like, we're learning about functions because functions are generally what you first learn about when you're trying to figure out how to write more complex Python code. But generally, when I actually sit down and write a Python program, I don't think in individual functions. I think in objects and classes and their interactions. And those interactions are mostly conducted with methods, which are functions that belong to a class, right? So very quickly, we're going to go from functions as a discussion point to classes as the main construct for building complex applications, right? So everything you know about modules and functions will apply to the classes as well, right? So functions serve multiple purposes. Primarily, they belong to they provide a means to group, right? These are the many purposes of a function. The functions group, name, and call logically related code segments. By grouping logically related code into callable segments, you reduce program size and increase code reuse and modularity. Okay? So over time, code quality improves as you work out the function's bugs. Now, to learn more about the origin of the term bug, you could read this link here, right? Functions increase code clarity. Assuming a function's name indicates its intended purpose or task, right? Adopting sound function naming practices makes it significantly easier to figure out what a program is supposed to do when you look at the modules and the functions. In this regard, I think novice programmers are short-sighted when naming functions, right? I've seen students make up function names that offer not the slightest indication of a function's purpose. And then they wonder why they can't understand their own code, right? Or how to fix it, right, when it goes bad, because they can't logically wrap their head around it. The moment you realize you're not naming functions for your own self-gratification, but for the sake of other developers who may come along later and try to decipher how your program works, is the moment you take your first steps towards becoming a professional software engineer. I can't emphasize that point enough. The moment you realize, I'm going to highlight this whole passage here, right? The moment you realize you're not naming functions for your own self-gratification, but for the sake of other developers who may come along later and try to decipher how your program works, is the moment you take your first steps towards becoming a professional software engineer. Well-named functions lead to higher code quality through clarified intentions and make it easier to spot and correct errors in the code. Finally, functions provide an atomic testable unit. And later in the book, when we talk about unit testing, you'll see what I mean by this. All right. Now, function design considerations. Keep in mind several design considerations when designing and writing functions. You want your functions to do one thing and do it well. You want the functions to stay within their swim lane. And by this, I mean the results of a function call must be predictable or deterministic. A function call should not mysteriously change some other part of the application surreptitiously. And to this end, you want to write functions that maximize cohesion and minimize coupling and minimize side effects, right? That's another quotable quote. Maximize cohesion. The term cohesion means the degree to which a function sticks to its intended purpose. All right? All the code contained within a function should exist for no other purpose than to fulfill the function's intended purpose. Okay? A function's intended purpose is conveyed primarily by its name. A maximally cohesive function wastes no time or resources executing code not related to its intended purpose. In other words, a highly cohesive function performs its intended task and nothing but its task. All right? Now, minimize coupling. The term coupling means the degree to which a function is interconnected with other modules or functions. Coupling is a measure of interdependence. Functions can be highly or tightly coupled or loosely coupled. If function A depends on functions B and C and D, then a programmer assigned to maintain function A must understand functions B, C, and D before they can fully understand function A. Also, as you will learn later when you encounter software design principles, any modifications made to functions B, C, and D will impact the behavior of function A. If in this example, function A is said to be dependent upon functions B, C, and D, right? So that's where you want to minimize coupling, because coupling means that if I depend on other modules and functions, right, then any changes to those dependent modules and functions will force a change in that function's behavior, right? And sometimes that can be anticipated. Sometimes it's a surprise, right? Minimize side effects. The finally, right, for section 2.3. Minimize side effects. A side effect is anything a function does not indicated by its name or intended purpose. Okay, I'll highlight that too, right? A side effect is anything a function does not indicated by its name or purpose. An example of a side effect might be where a call to change first name function also changes the last name. Another example of a side effect would be calling the same change first name function and it also prints a message to the console. So just think about that, right? Like whenever a function does something, you don't want it to be doing something else that's not implied by the name of the function, right? Now, this doesn't mean that you can't have logging in your application to trace what's going on, right? But generally speaking, printing something to the console is a side effect, right? You want to kind of minimize those things. Now, at their worst, undocumented side effects wreak havoc on application state. Some types of side effects are less insidious. Printing a message to the console, while not likely to crash an application, is still considered a side effect. All right, so next thing we're going to do is we're going to talk about defining and calling functions. All right, so defining and calling functions. Defining and calling functions. So it's time now to dive deeper into functions. And in this section, you'll learn how to define and call functions, how to name functions, how to define function parameters, how to pass data into a function using function arguments, and how to define positional and default parameters. You'll also learn how to return single and multi-value data from functions. All right, now everything that you're going to learn about functions applies to methods when you learn about classes. So just keep that in mind. Okay, before you can use a function in a program, it must be defined within a module. The function can be used within the same module, or the module can be imported into another module that requires its services. So let's see this in action, right? So, anatomy of a function. Let's start by showing you the anatomy of a typical function shown in example 12.1, right? So here we have a function called print hello world. And in it, on line 2 here, we've got print, and then we're printing a string to the console, okay? The name of the function is print hello world. It's printing hello world to the console. All right, very simple example. Doesn't violate too many principles there, right? All right, so let's take a look and actually create a project with this code, and then we'll start building upon these examples, right? So I'm going to go to my console. I'm going to change cd dev dir dev.temp and dir. Okay, so cd, actually make dir functions. Right, hello world. Yeah, I'll just do this. Greetings. Code dot. Now, go back to the book. And it says this is called greetings.py, and it has def print hello world. All right, so code. Let's go to Visual Studio Code. All right, so I'm in the greetings directory, and this is greetings.py. And one more time, let's go to the book. Greetings.py. Okay, so print hello world. Print hello world. So let me close this window down. Let me slide this over. And let me, I think I can do this, make this bigger so you can see the text better. All right, so this will be demo. Demonstrate functions. Print hello world. Okay, so and then print hello. I'm going to use a formatted string. That'll be the difference between this and the book. And then this will be, yep, I can do it this way. Hello. Hello world, like that. Save that file. Now, let's take a look at, back to the book. All right, referring to example 21.12.1, the definition for the print hello function starts on line 1. Here we have a def keyword, and then the name of the function, and open parenthesis and a close parenthesis. This is the function definition, and then the colon, all right? And then this colon marks the start of the body of the function. The body starts on line 2. And notice how the body code is it's either 4 spaces or 1 tab, okay? And sometimes, you know, in your integrated development environment, if you make a mistake and tab over or use spaces, and sometimes the tabs get out of whack or the spaces get out of whack, right? So in Visual Studio Code, you can go up here to the quick access bar, click on Show and Run Commands, convert indentation to tabs, and that will usually fix your problems if you have problems, right? If I run into an example where I'm seeing the red because of the indentation in the tabs, I will do that again and draw your attention to it, right? So here we have a module name, greetings, and the greetings defines a function called print hello world. Okay, let's go back to the book and see what the book says. Okay. Okay, so now this is, like I say, you got the def keyword, the name of the function, open parenthesis, close parenthesis, and the colon. That is usually the first line of your function definition, right? And then the body code starts on the second line of the definition, right? Now the definition means you are defining what this function will do, okay? So, all right. The PEP 8 recommends spaces instead of tabs down here, right? It recommends 4 spaces. But you can use either or. But you can't usually mix both, right? So that's why you have to either have spaces or tabs. Okay. So generally speaking, right, this is important. Any number of lines of code can appear within the function body, but you want to keep the function definitions as short as possible for clarity. Long-winded functions can prove difficult to understand and can usually be refactored into several shorter, more cohesive methods. I think a rule of thumb, and this comes from like back in the days when they were using gotos, right? We don't use gotos generally in Python, but I'm looking for Visual Studio Code. Okay. Assuming this is we have this function here, and this is one line of code, right? If this function had more lines of code than, let's say, 1 full page, like let's say 80 lines of code, right? And it spanned 2 pages of printed out paper, you might want to shorten that function or refactor that function into functions that do more cohesive things, right? Your function may be doing too many things. And that is kind of a nebulous measurement, right? But if your eyes have to jump too far from the beginning of the function to the middle and the end of the function, your function is probably not optimally thought through, designed, implemented, etc. Right? Just something to be aware of. On the other hand, it may very well be like it takes 80 lines to get something done in your function. But that is just something to think about, right? So let's go back to the book. All right. Now I'm going to write another module called main. And we've seen this before, but I'm going to just reiterate it, right? And in the main, I'm going to import greetings module. I'm going to create a main function. And then I'm going to call the greetings.print hello world. And I'm going to run this main module from the command line. So I'm going to have this line 6 in there. By now, line 6 should be you should memorize line 6. It should be internalized. And in fact, this whole main structure should be internalized as a idiomatic entry point for a Python program. Okay, so let's go back to Visual Studio Code. And I'm going to add the main module, so main.py. And here I'm going to, excuse me. All right, so I'm just going to say, demonstrate, I want to say entry point for a Python program, right? Save that. Now I'm just going to come down here and go def, right? Defining a function. The name of the function is main in this case. And then I'm going to, first I'm going to import greetings. And then down here I'm going to say greetings, print hello world. And then down here on line 11, I'm going to say if the name property underscore name underscore attribute for this module equals underscore main underscore. If it equals that string, then call main. That means that ran it from the console. Now, excuse me. Let's go to terminal, clear the screen, dir, so you see main and greetings.py, Python 3, main.py, hello world. Okay. Let's take a, let's do this. I'm going to run, well, actually, I'll do it later in the code, right? So let's go back to Visual Studio Code. Actually, let's go back to the book. All right, so we ran this and we get hello world. All right, I capitalized these, so it's going to look a little different from the book. So naming functions. So like modules, function names can contain lower and uppercase letters, A through Z, uppercase letters A through Z, numbers 0 through 9, and underscores. Again, for function names, PEP 8 advises the use of all lowercase letters, short function names, and use underscores to separate multi-word names for the sake of clarity. So if we revisit this, this name here, so I'm going to go back to Visual Studio Code. So the name of the module is greetings, for the greetings module, and then the greetings module defines a function called print underscore hello underscore world. So that's a multi-syllable function name. The multi-words are separated by underscores, okay? And then that's it. Main has a very, short name. It has a function called main. This is the module. This is the function. All right. Now, if I print out, let's do this. Let's print dir print f. I'm going to say dir dir greetings. Let's see if this works here, right? So dir is a built-in function that will print. Let's just see what it does. Dir greetings. So we're going to get some metadata about this module. Okay, let me just look this up real fast, right? So I'm going to go to a new window in my browser, and I'm going to look up Python dir, right? And it's a built-in function. It returns a sorted list of valid attributes and methods for an object, okay? The built-in dir. So it's a built-in function. It's a built-in function, and it's going to give me a sorted list of attributes and methods for this module. So let's see what it gives us, right? All right, let's go back to the console. And now I'm just going to run this program again. So here's our built-ins, right? So there's no built-ins, doc, file, loader, name, package. So what we have here is we have this attribute, built-ins, right? We have cached. We have doc. Doc means doc comments. Let's take a look at the doc comments, right? Because we do have some. If we go back to Visual Studio Code, we see that we have this doc comment up here, right? And in greetings, we have this doc comment. So let's go ahead and print out that attribute. So let's go back to main. And let's print out, so that's the dir for the greetings. Let's print f, I'm going to say doc, I'm going to say greetings, escape, greetings dot underscore underscore doc underscore underscore equals, and then greetings dot underscore underscore doc. All right, just like that. Now let's see what this does. Let's go back to the console. CLS. Okay, so here is our doc function. There's our doc property, and there's the demonstrate function. So that string is the doc function or the doc comment for the module, right? So let's go back to Visual Studio Code, and you can see up here, there is the doc comment, demonstrate functions, right? That's what these three things. Okay, so the dir allows you to, now, so we can also do dir on, I think we can call the dir on the actual like function itself, right? So let's try that. Maybe I don't know if this will work, but we can see. Print f greetings. I'm going to say dir greetings dot print hello underscore world, like that, equals. All right, let's see if that works. This may or may not work. All right, so let's go to the console. Let's go back to Visual Studio Code first. Make sure I saved it. Yep, I saved it. CLS. All right. So now this is the dir greetings hello world. Now hello world, which is a function, has these attributes: annotate, annotations, built-ins, call, class, code, defaults, dlat, dictionary, dir, doc, equate, subclass hook, string. There's all kinds of stuff, right? Like, this is what I'm trying to say, right? A Python program is a bunch of metadata, right? All right. So CLS. Let's go back to the book. Now, so returning to function names, use verbs in function names. Print hello world. All right. Verbs clarify as much as possible what the function is supposed to do, how to perform. And then later on, there's like in chapter 4, the project walkthrough. If you want to see how to perform a noun verb analysis, see page 120. Now, functions can start with a leading underscore, right? Doing so has special meaning. It signals to those using the module that the function is only to be used within the module and not as part of the module's public interface. That's very important. It's like a Three Musketeers agreement. If I start a function name with an underscore, it signals to the rest of the people using this module that you should not call that module directly, that it's being used internally, and you can use any function or whatever that doesn't start with an underscore. And in some ways, depending on how you import the module into another module, you can limit the visibility of the underscore functions, right? Python does not support data encapsulation like Java and C# or, C++, right? So that's why it's mostly just a gentleman's agreement. Okay, function names that do not begin with a leading underscore are considered part of the module's public interface. And then again, this is all agreed upon with a Moose Lodge secret handshake, as Fred Flintstone would be very aware of, right? If he was a Python programmer back in the day, right, he would understand what a Moose Lodge secret handshake is. Okay, calling functions within the same module. So let's talk about that. Calling functions within the same module. Now, the key takeaway here is if you call a function within the same module that you define it, you must define the function before you try to call it. So let's take a look at this code right here. Here I have comments, okay? And then I'm trying to call print hello world, but I have not defined print hello world. In fact, the definition for print hello world starts on line 11, print hello world. I'm trying to call print hello world here. That's a direct call in the module. Here I'm putting print hello world in a function definition. So this is technically, I'm defining a function that calls print hello world, but I'm not actually calling print hello world until I call that function defined on line 8, right? But here's print hello world. Okay, now if I call it directly here on line 16, this works fine because I've defined it here. So let's see this in action, right? So I've got print hello world. I'm going to try calling it up here within the same module. Let's go back to the code. So this is what I mean. I'm going to go back to greetings, and I'm going to do this, right? So I'm going to say comment. This causes an error because it's not yet defined. So if I say print, now here I'm just calling it hello world, right? And it's going to say, look, I have not seen this, right? So it's telling me it's not defined yet. But if I come up here later and go print hello world, right, then that will work just fine. Notice there's red here because my ID is warning me that you can't do this because the definition doesn't appear until after this call. All right. So I'm not even going to run this program because it's going to throw an error, right? So now down here, I guess I could say this. I could say call print hello world. So this is technically another function definition. And I'm going to call print hello world, right? And this is fine because this is a function definition that then in the body of this function definition makes a call to print hello world, but it's not actually being called. It's just defining a function call because it's not actually being called until this gets called by some other module, right? Now this would execute when this module gets imported into a main, right? Because it's at the leftmost. But anyway, this is not an example of great Python programming. It's just to make a point, right? Anyway, I'm going to get rid of this because we don't need it. And let's go back to the book and continue on. All right. Some of this stuff is just, for just to clarify your understanding of how things work. Now, calling functions from an external module, right? There's different ways you can import. So if I go back to Visual Studio Code and go to main, then we can see here that I'm saying import greetings, which imports everything that can be imported from the greetings module into this program. And I'm going to get rid of all this other stuff. We don't need it. There's another way to import stuff too, right? I could say from, I'm going to comment this out, say hashtag, and I'm going to say from greetings import print hello world. And then also too, if I want to, I can do it this way, I could say from greetings import call print hello world, because those two functions are defined in that greetings module now, right? Now I don't need, because I'm saying import print hello world, I don't need the module name in front of this anymore, like that. So print hello world and call print hello world. So I have direct access to those now without the module name. Now you can change the name of what you're importing. You can say from greetings import print hello world as, let's say as PHW. Let's see, print hello world, right? Now if I want to call this function as print hello world, I can say PHW. HW, right? Let's get rid of this call print hello world. Okay. Now if I run this, I'm saying import this function as print hello world. Let's run this code. And it works, right? Shocker. Of course it works. All right, now let's go back to, it's not intuitively obvious that you can do that, right? You can name, but you can do it with module names and you can do it with function names and class names. Just about everything that you can name, you can import it as some other name. And the reason you'd probably want to do that is to avoid naming conflicts if you were using third-party libraries that had naming conflicts, okay? Let's go back to the book and press forward. Now you can automatically exclude internal functions that begin with a leading underscore from being exported from a module by using asterisks when importing. So let's take a look at this. Let's go back to the greetings. Let's go back to Visual Studio Code. And let's define, let's say this call print hello world is an underscore, call print hello world. Let's go back to the main, and we're going to go, I'm going to get rid of this. We saw that works. And I'm going to say from greetings, import star, right? Now, if I try to print something, I'm going to say print hello world, like that. But if I try to print underscore call world, call print hello world, like right here, call print hello world, call print hello world, right? This starts with an underscore, and because I'm importing, I say from greetings import star, and I try to just say underscore print, it doesn't show up, right? So it's not exporting that. It's keeping those underscore functions to themselves, right? Here it just says import everything that's a public interface, essentially. And again, because I'm going import star, right, I don't have to use the greetings package name on this function. So let me run this just to show you that it works. Very nice. Okay, let's go back to the book. Now, so I've added the internal function. Now we can also explicitly name imports within a module. So the asterisk imports every function from a module that does not begin with an underscore. Okay, and you learned earlier that function names beginning with a leading underscore are meant for internal module use only, while modules that do not begin with a leading underscore are part of the module's public interface. So you can explicitly define which functions belong to a module's public interface by adding an all property to the module. So see how this is done? Let's take a look at example 12.8. So we have underscore underscore all equals a list. That square bracket means a list. The name of the function. So I want to export print hello world. So let's go back to the code, right? Visual Studio Code. I'm in the greetings module, and I'm going to say, let's go back to the book real fast. I got a memory like a Sith. Underscore underscore all equals a list, okay? So underscore underscore all equals assigned a list. Go back to Visual Studio Code. A list. And I'm going to say print hello world. Now I'm going to leave that like that. I'll make this call print hello world, and then under here I'll say def internal function. Oops. See, I'm so used to using C++. All right. Print hello world, like that. So this is an internal function. That's another function, but I'm not actually exporting it. So now how would I do this, right, in the main? So let's go back to the book. Now, the all property defined on line 1 lists print hello world as the only exportable function. Now when you use the asterisk to import everything, only the print hello world function is accessible, okay? So, all right, so back to the code real fast. That's why I changed this. So we technically have two public interface functions, but I've only said that this one, print hello world, is the only function I want to export. So if we use the asterisk again, then we will see that we can hit print hello world. But if we say call hello world, it doesn't show up in the IntelliSense, right? So it's not being exported. So this all property can be used to specifically say which functions in your module you would like to export. Okay. This is all good to know stuff, right? And allows you to fine control what can and can not be seen, or to hide the implementation from the interface, essentially. Because what you're making when you create a module is an interface to your program. And I'm guilty of this too. Like when I'm in the heat of battle and I'm programming, I don't really think much about the interfaces because I'm usually the only one using my stuff, right? But if I was a little bit more on my game with thinking about interfaces, then I would just make sure that the only thing a module exported was what was necessary to use that module in some other piece of code, right? So let's now go back to Adobe Acrobat. Okay, so some parting thoughts. All right. I recommend, like I did, right? I recommend you run those previous examples in Visual Studio Code to see the effects of using the various types of imports, right? Only then can you see which functions are available for use within the importing module. Later, I'll show you how to import module and give it an alias. I did that already, so we've already seen that. That's where I imported the function, but I changed the name to PHW, right? So those are aliases. And you can alias the module name, or you can alias the function name, or you can alias a class name. All right. As far as which import form I recommend, it's handy to know which namespace, i.e. which module name a function belongs to as you read through the code. So I generally favor importing the whole module, like import greetings, right? Or importing specific functions from the module, like from greetings, import hello world. This way, when I read through my code, I can see at a glance which module a function belongs to, right? Greetings, hello world. There's also a way to import multiple functions, right? Let's go back to the code. Just a parting shot. This is not in the book, not the way not in this version of the book anyway. But let's say I wanted to just export everything, right? So I got rid of this. Okay. Now I'm exporting all this stuff. But if I go to main, then I want to specifically say from greetings, import, and then open parenthesis call, print hello world, and call print hello world. So this is another way of just saying, of grouping. You can use parentheses to group the specific functions you want to export, right? And then if I wanted to call underscore call internal, yeah, see, it's not available because I'm not actually importing it, right? So that's another way to specify which ones you want to import when you have multiple functions you want to import from a module, okay? Or multiple classes or multiple whatever. All right, so back to the code. Back to the book. Okay, that's next thing I want to talk about are function parameters and arguments. Okay, let's talk about function parameters and arguments. Now, as you learned earlier in this video, you can pass data to a function using function parameters, and you can get data back from a function using function return values. Okay. Before we get going, let's take a look at some vocabulary. So the term parameter is simply means a variable that is defined that will be used in order to feed data into a function. An argument is the actual data that is supplied to the parameter when the function is called. Okay, so in this particular example, 12.12, we have a function called greetUser with a parameter named username, and then it prints hello username to the console. So I'm going to go ahead and implement that, and we see what that looks like in the code. So I'm going to go to Visual Studio Code, and come down here, and I'm going to say def greet user, and then username. Username is the, let's go to the book and make sure I got that right. Let's go to the book. Yeah, user underscore name. Okay, user underscore name. Go back to Visual Studio Code. I don't want to go too far from the book. Okay, but what I am going to do here is I'm going to add a type hint and a default value. So Rick. All right, now I'll explain what I'm doing here in a second. And I guess I'm going to go ahead and say this returns none. Right, so it doesn't return a value. Okay. And then print formatted string hello, and then username, like that. Okay, now I can call this function a couple different ways. First off, let's go to main, and let's get rid of these. I don't need these anymore, so get rid of those function calls. And I'm just going to say greet user, import greet user. Now I can call greet user with no arguments, and in that case, it's going to say it's going to supply this default value to the username parameter, and it'll say, let's say in this case, if I don't supply any additional arguments, it'll say hello Rick, right? So let's just run this and see if that's the case, right? So let's go to the console, CLS, Python main, and we say hello Rick. Okay. Maybe I could jazz that up a little bit. Let's go back to Visual Studio Code. And anyway, I'll leave it just like that. So greetings, hello Rick. Now we'll go here, and we'll supply an argument to that function, right? So greet user Corley, like that. Run that code one more time. And we got hello Rick, hello Corley. So CLS. Let's go back to Visual Studio Code. All right. So essentially, we have this function that defines a parameter named user underscore name. The type hint is a string, and it's only a type hint. I'm not even checking to make sure that it received the string as an argument. I'll talk more about that later in the book. Okay. And it returns none. Okay. This is just a signal. It could return something, but it's not. And I'm signaling the fact that it doesn't return anything by saying the return value, which is a hyphen and a greater than sign, and then followed by a type. Right? See, I just kind of dorked that around myself. None. All right. Now, let's go back to the book and move forward. So function parameters. We know about f strings. So now let's talk about the 5 different types of function parameters. Okay. Starting with positional or keyword. So I'm going to modify this function, and I'm going to give it 3 parameters, and then we'll pick up the conversation from there. So let's go back to Visual Studio Code. Let's go back to greetings, and we're going to say first name. I'll get rid of this stuff here. I'll say first name, string, middle name, last and underscore name, string, returns none. Okay, so hello first name, first name, middle name, last name. Okay. Now, when we run it, there are no default values. Okay. So I'm going to have to supply arguments, and I'll just say Rick, comma, W, and then Miller. Now notice that when I call the function, I'm supplying these 3 string arguments that correspond to these 3 parameters. So the first argument I supply is going to be assigned to the first name parameter. The second argument that I supply is going to be supplied or assigned to the middle name parameter. And the last string argument I supply will be assigned to the last name parameter. So let's run this code and see what the output looks like. And all right, so it says, hello, Rick W. Miller. Let's go back to Visual Studio Code. Now, the beautiful thing is these are positional / keyword parameters, okay? So I can call the greet user function and assign first name equals Rick, middle name equals W, and last name equals Miller. So now in this case, these are positional arguments. So these arguments are assigned to the parameters based on their positional, the order in which they were declared, their position, right? So first name's first, middle name's second, last name's third. I call the function. Rick is going to go to the first parameter, W is going to go to the second parameter, and Miller is going to go to the third parameter. I can also assign the parameter by the argument by keyword. I can say Rick goes to the first name parameter, W goes to the middle name parameter, and Miller goes to the last name parameter. The beautiful thing about doing keyword assignment, right, is, let me just copy this. It doesn't matter the order that you make these assignments. I could assign middle name first. Let me grab that comma. Control X and assign that first, right? I can do middle name equals W, first name equals Rick, last name equals Miller, and this will work just fine because the function knows where to put the arguments at. It knows which parameters to assign those to. So when I hit clear screen and run it, then everything works great, right? So that's the first argument type, right? Or the first type of parameter, and that is your positional or keyword. All right. Now, that's usually the way I roll. Like I usually just do that, right? Like I define a set of parameters. There's keywords for each parameter. Obviously, it's the parameter name is the keyword. And then when I call the function, if I need to, if I know the positions, I'll assign them. But I usually explicitly set the parameters by keyword, okay, because that tells me that I know exactly this is how I want to call this function, so I don't screw it up, right? But however, I just want to go over these other 4 types so that you're familiar with them, right? So back to the book. The second type is positional only. So you can force arguments to be passed positional only by adding a / at some point in the function definitions parameter list. So I'm going to go back and I'm going to add a /. Okay, so now if I add a / to the definition here and a comma, then what it does is this / applies to the any parameter that's in front of it. So it applies to this parameter first name. And it says this parameter must be position only. It cannot be a keyword parameter. So now my code's going to break because I'm assigning the first parameter by keyword. So I have to get rid of this. Then that makes that function work fine. And then I have to get rid of this, right? I have to, let me get rid of, I have to reorder this because this is not going to work. So Control X. And then I have to get rid of the first name because this first name is positional only. And then these next two can come in any order. So I could actually put that right there if I wanted to. Last name, middle name, right? Middle name, last name doesn't matter because those are keywords. And as long as the keywords are correct, then they're going to be assigned to the correct parameter. Save. Run this again. Clear the screen first. Run it, and everything runs fine. So that's positional only. So if you want to designate some of your parameters positional only, use a slash. Now let's go back to the book, and we'll talk about the third type of parameter, and that is keyword only. The keyword uses the asterisk, but the difference between the slash and the asterisk is the slash applies to the preceding parameters. So the slash applied to first name, whereas the asterisk will apply to any parameters that come after it. So let's go back to Visual Studio Code. Let's change the slash to an asterisk. Now my code's going to break again because what this is going to say is these parameters over here can be optional positional or keyword, but these must be keyword, right? So let's go to main. So this right here, so that's fine, that's fine, that's fine. Middle name has to be a keyword, right? Miller has to be a keyword, right? Last name, Miller. And then it doesn't matter what order they're in, but this could be either or. So here I could say first name if I wanted to. I could say first name. First name equals Rick, but these have to be. And because of that asterisk, this is an optional positional or optional keyword, the first parameter, but the second and third parameter have to be keywords. You can't take away the parameter name. So save that and let's run it. Oops, I hit mail. I shouldn't have hit mail. All right, let's go to here. Let's do a clear screen. All right, so that works great. Now let's go back to the book. Now the fourth type of parameter is called var positional. So again, the fourth type of parameter type is var positional. So sometimes you want to pass in a variable number of positional arguments to a function. In times like these, you need to use the args, right? So these are positional, right? They're not keyword args, they're positional. So, this is this version of the greet user function, right, will allows for people with more than 4 names. So let me just go ahead and implement this one here. So def greet user first name, and then position args, or star args is the name of it, and then hello first name, and then no line, and then for S. Okay. Okay. Alrighty, now let's do this. So I think I know how to do that by looking at it. Let's go ahead and change this definition. This will be star args. Get rid of this. Get rid of this. So first name is still there, comma, end equals like that. Okay, and then for arg in args, right? Print f, and then arg like that. I think I'll do this. Put a space there. Comma. End equals. And then when I'm done with all that, I'm going to say print exclamation point. Like that. Okay. Now let's go back here. And all right, so these guys can be, I can do this, I can do this, because they're positional arguments, right? They're not keyword arguments. First name can be is positional or keyword. Last name is positional. All right. Let's just make sure I'm okay here. Maybe, oh, I see. All right, well, let me see here. So Rick, I guess this has to be positional. It's giving me the error. Okay. Okay, so now there's really only one. I guess it doesn't really matter here, but let me go Control X, V. Now we can supply variable number args here, right? So I'm going to say Rick W. Miller, Jr. I'm not a junior. Oh, Esquire, ESQ. Right? Comma. Oh, I could just be Rick Warren. So maybe that last one just has 2, right? So these are all positional. So now if I run this, then all of these different versions of this function will work, right? So go back to clear the screen. There we go, right? So I'm adding this exclamation point to the end of it. So hello, Rick W. Miller. Hello, Rick W. Miller, Esquire. Hello, Rick Warren. All right. So let's go back to the book. And we got one last type. Let's scroll down here a little bit, and we're going to say var keyword. So to pass an arbitrary number of keyword arguments, use the star KWARGS parameter, right? So now this is a dictionary, whereas this args was a list, or the star args was a list. The star quargs, KWARGS, or keyword args, that's a dictionary. So the way that we iterate through there is we have to say for key value in KWAR cargs dot items, print key equals value indel, or end, right? So let's go back to Visual Studio Code. And let's go to greetings. So let's turn this into KWARGs, right? So star KWARGS, right? So for key, I'm going to say keyword value, key value. So for keyword value in KWARGS, right? I'm going to say parameter because that's more like what we're doing. So for parameter value in quargs, right? So print parameter equals value, like that. Okay. And then, yeah, okay. So let's run this now. We go back here. These are all a variable number of keyword arguments. So this has to be like, instead of positional, these have to be, so I'm going to say middle name equals last name equals middle name equals last name equals title equals, and we'll say middle name equals, because it's a variable number of these keyword arguments, right? And I guess I could tighten this up. So now let's run this, and we're going to just iterate over this dictionary of these keyword arguments and print them out, see what they look like. So clear the screen and run it. Oh, and it says main, middle name, last name. It says too many values to unpack, expected to. Okay, parameter value in quarks. Let me pause for a second here and get back to you. Yeah, I know what the problem is. So let's go to Visual Studio Code. This has to be, so here I'm just doing the dictionary. This has to be items. Sorry about that, guys. All right, so this has to be for parameter. Items returns the key value pair, right? So you can name these things anything you want, right? So I'm going to say parameter value, because quarks.items returns a tuple, a list of tuples, essentially, right? So, and each one has a parameter and a value, or a key value. So key, I'm calling parameter and value. So now when I run this, it should run. So I go back to the console, clear the screen. There we go. So hello, Rick, middle name W, right? Because I'm printing these out, right? So W, last name Miller, middle name W, last name Miller, title Esquire, middle name Warren. Okay, and that is it. Let's go back to the book. Okay, so optional arguments. Now, okay, so you can make arguments optional by supplying parameters with default values. And you saw this, an example of this earlier, so I'm not going to go back in there. Type hints, I talked about that. Checking an argument's type. Here we can use the isInstance built in, and we can say, hey, is this parameter of type string? And if it is, then we can say, okay, great. Or if it's not, we can raise an exception. Arguments must be strings, right? So I'll go ahead and implement that, and I think that will be it for returning data. I guess we got one more section. So let me do this. Okay, so checking an argument's type. Let me go to the code, since we're talking about this stuff. All right, so I'm going to go here to greetings, right, for parameter. But first up here, I'm going to say if, let's just say, we'll do it on the first name. If I is instance, first name is a string, right? Then fine. Right, do nothing. I would say if not is instance. If not is instance string, then raise exception. I'm gonna go see how I did that in the book, right? So go back here. Raise exception, arguments must be strings, right? Very simple. So I'm gonna go back to the code. Raise exception. And then give it a string. Must strings. So let's give this a whirl, and we'll say go to main, and we'll give it one, and we'll say greet user one, like that. So the type hint says it should be a string, right? It says literal one is not assignable to string. So I don't need a semicolon there. So let's go ahead and run this and see what happens. Obviously it's going to error out, CLS. All right, so here it runs, right? Because it's a runtime error, essentially. It says, hello, Rick, that ran fine, that ran fine, that ran fine. And then when it come here and it said, oh, you know, this greet user had one, and one was assigned to the first name, then I raised that exception, right? Arguments must be strings. So I'm the one that caught that exception, right? Python didn't catch that. But, my code caught that fact that it was a integer and not a string. So that's how you have to kind of, if you're interested in making sure you don't get the wrong types, you got to check for those incoming types, right? I'll talk more about this as we progress through the book. So let's go back to the book. Checking an argument's type. That was pretty easy. Now we're going to talk about returning data from functions. And I think after we do that, functions are first-class objects. So there's two more sections. And this functions are first-class objects is really fun, right? So let's talk about returning data from functions and functions as first-class objects. Okay, returning data from functions. So Python functions can return data. Most functions you write will accept arguments, process those arguments, and return the results somehow, right? So example 12.21 right here provides a new function called create greeting. Now let's just take a look at create greeting, then I'll implement it in Visual Studio Code. Def create greeting, first name, middle name, last name, and it returns a string. That's a type hint. Okay. If is instance, first name, and is instance, middle name string, and is, so I'm checking all the parameters to make sure they're strings. Then if they are, I'm going to declare a new variable called greeting, create the greeting from the parameters, and return the greeting. Else, I'm going to raise an exception if those are not strings. Okay, all those are not strings. So let's go to the code, Visual Studio Code, and I'm going to say, so I get rid of this. I'm going to say create greeting. It's not create. I don't have that function yet, so I'm getting ready to create it. So create greeting. Just come up here to the top, def create greeting. It'll have first name. That'll be a string. Middle name, string. Last name, string. And this function will return a string. Now these are just type hints. Like I said, right? This is not type checking. This is just type hinting. So I'm going to say if, okay, if is instance first name str. Now this is checking to make sure whatever the first name parameter is, that it is a string, right? It equates and is instance, okay, middle name str, right? So I'll do it like this: if and is instance last name last name, string. Okay, if that's the case, then I'm going to come down here and say greeting equals f string, first name. Oh, hello. I'm going to say hello. Hello. First name, right? Middle name. Last name. Return greeting. Else. Okay. Else. Raise. Exception. Parameters must, or I should say arguments must be strings. Like that. Now I'm going to call this function in the main. So I'm going to say print, and I'll say create greeting, Rick W Miller, right? So there's the first one. And I'll say print create greeting. Corley. Okay. There we go. So create greeting S Powell. Okay, so there's two. Now let's go ahead and say print create greeting, and let's just check our error checking, right? Make our enforcement of the strings, and I'll say 1, 2, 3. So all those are not strings. So let's run this, and again, this will be a runtime error, right? Because CLS Python made. Yep. Okay. So this first one ran, right? The first string was fine. The first arguments were fine. The second set of arguments were all strings, but this third set were just 1, 2, 3, and so it's throwing the exception, right? And the exception is create greetings. Oh, create GRE. Yes. Oh, create greeting. All right. So let's go back to the code. It's telling me I'm calling the wrong function name, and I am. So let's go here, create greeting. Now it's giving me the red on the numbers, which it should, right? Let's go back to the console and clear the screen and go Python. There we go. So now we're getting the 1, 2, 3 is the problem, and the exception is raised. Arguments must be strings, and that's the way it should be. Okay, so that's how you return a value, right? In this case, we're going to go back to the code. I'm just returning a string value. Functions are first-class objects. What does that even mean? Okay, so here's, I think, the real power of Python and functions, right? And this is like a tentative foray into the first concepts of functional programming. But Python treats functions as first-class objects. In other words, functions can be assigned to variables and passed as arguments to other functions. And so this makes for some really interesting code. So let's take a look at this example here, and then I will implement this. I think I already have it, so I'm not going to code the whole thing. I'm just going to pull up the example. All right, so this is obviously on my repository for this code. This is example 1229, the calculator.py. So I'm returning the calc function, right? The non-underscore version. And so the calc function takes a float. It takes 3 arguments. It takes a float, another float, AB, and then op, which is a string, and returns a float. So we start off up here by saying, okay, we're going to export the calc function, and we define add as a lambda function. And we haven't really talked about lambdas, but it's not a hard concept. Lambda A, B, which means define a function that takes 2 parameters, A and B, and then performs that operation on them. So add is a function that has 2 parameters and adds those 2 parameters and returns the value. Subtract, or sub, is a function that takes 2 parameters and performs a subtraction on those parameters. Okay. Multiply is a function that takes 2 parameters and multiplies the parameters together and returns the result. Divide, div, is a lambda, or a function, right? This is just a shorthand way of defining a function, and divide the parameters and return the result. Okay, so here's how we do this, right? So we've got these add, subtract, multiply, divide functions, and then we're going to call calc AB with the name of the operation. So what we do is we pass in a string or a symbol that says, okay, I want you to, it's like a postfix calculator, right? So AB plus. So we go result equals 0, match match op. So if the op coming in is a plus sign, then the result is underscore calc, right? AB add. So op is callable. So that's different from the op string, right? It's callable, and a callable is a function type. So if you want to pass a function to a function, the variable type or the parameter type, if you're going to do type hints, is callable, right? So this tells me that A is a float, B is a float, and op is going to be a function or a method, okay? Anything that's callable. So I'm passing in the case of the underscore calc, I'm passing in the add because that's the operation that needs to be performed. Now, in case the op is in subtract, then call AB with sub. If it's a multiply, then call AB with the multiply function. And if it's a divide, then call AB with a divide. Now let me get this code. Let me go to the actual project and the repository for this, right? I'm not going to try to code all this up right now. So I'm going to go to my console, CLS, CD, dev, dir, CD, actually CD, dev, CD books, dir, CD dev.books. CD CST with Python first edition. Let me see. Make sure I got the latest. Yeah, there's a lot to get. Okay, so CD. Let's see, do it. dir. CD chapter 06. Hang on a second. I'm sorry, I'm chapter 12, CD, chapter 1, 2, CD, chapter 1, 2. All right, so var positional, function parameters, functions, first class citizens, CD function, first class citizens, dir. calculator main. Okay, so code dot. All right, so here's the code for that. Sorry it took me so long to find that project. All right, so I'm going to make my Visual Studio Code bigger so you can see it. Let's pull this up here. Let's come down this way a little bit and make it just a little bit bigger. All right, so we should be able to see it now. Let's go to calculator first. And so there's the code that was in the book. And here's the main. So here's how it's being run. So we import everything, which is going to import everything except for the underscore, right? And the fact that we've got this all in there means that the only thing that's going to be, the only function that gets exported is this calc function, right? That's the public interface. And then in the main, we say print f. So we're going to print this string 1 plus 2 equals, and then calc 1, 2, and then pass in the op string. And then in the code, the op string is going to go, oh, hey, case op is a plus, then call the result is underscore calc a, b, add, and then return, or call that underscore calc and then return the callable, right? Or return the result of applying the op, which is this function up here, which is the callable function, to the parameters a and b. So let's go to, so let's run this code and see it run. All right, so let's go back up here. CLS, dir. So we're going to run main. So CLS and Python main.py. And there is the results of running that example. 1 plus 2 is 3, 2 minus 4 is -2, 5 times 5 is 25, and 14 divided by 7 is 2.0. Let's go back to the book. Okay. Parting thoughts. That's it, pretty much. This has been just a good, pretty solid introduction to function modules and functions, and this stuff, plays a very important foundational material for understanding what comes next in Python. All right, so there's the chapter. Read the chapter again if you want, and I will see you in the next video. Thank you very much.